You don't see the world. You hallucinate it. What if I told you that the world you're looking at right now isn't real? At least not in the way you think it is. See, as you're watching this, billions of neurons in your brain are working around the clock to create your conscious experience. But this isn't a simple live feed. Your eyes aren't just little cameras sending a video signal to your brain. The real process is way more complex, much more creative, and honestly, a whole lot weirder. According to neuroscientist Anil Seth, you don't really see the world with your eyes at all. You see it with your brain, and what your brain is doing, essentially, is hallucinating everything, all the time. Now don't worry, you're not going crazy. You're just experiencing what's called a controlled hallucination, and I'm going to show you exactly how it works. To really get this, we have to throw out a huge misconception we all have about how we perceive things. Most of us think it's an outside-in job. Light hits our eyes, sound hits our ears, and that info travels to the brain, which then stitches it all together into a picture of reality. That's the classic way of thinking about it, and it's basically wrong. The reality is, your brain is locked inside the dark, silent vault of your skull. It has zero direct access to the outside world. All it ever gets are streams of ambiguous electrical signals, pulses from your eyes and ears that are just signals. So how does it turn that chaotic electrical chatter into the rich, stable, and colorful world you experience every single day? It guesses. Seriously, it makes predictions. Based on a lifetime of experience, your brain is constantly building a model of the world. It's making its best guess about what's out there that could be causing those sensory signals. And what you experience as reality is that best guess. It's a story written from the inside out, not read from the outside in. This is the core idea of what's called predictive processing. Perception isn't passive, it's an active, creative act. Section 1. The thesis, the brain as a prediction engine. Think of your brain as a prediction engine that's always a step ahead. It's not just sitting around waiting for information to arrive. It's actively predicting what that information is going to be. As you walk into your kitchen, your brain is already predicting the counters, the fridge, the light from the window. It sends these predictions down from the higher parts of your brain to the lower sensory parts. Now, when the actual signals from your eyes arrive, they get compared to the prediction. If they match, if the fridge is exactly where your brain said it would be, not much happens. The signals basically cancel each other out. Your brain goes, "Yep, called it," and saves its energy. This is super efficient. But when there's a mismatch, that's when things get interesting. We call this a prediction error. If you left a coffee mug on the counter and it's not there, that error signal is what gets sent back up the chain. It's the signal of surprise. Your brain prioritizes that new information and uses it to update its model of the world, so the next prediction will be more accurate. So you never actually perceive the raw data from your eyes. You perceive your brain's hypothesis about the world. This is what Anil Seth calls a controlled hallucination. It's a hallucination because it comes from inside your brain, but it's controlled because those prediction errors from the real world are constantly reining it in, keeping it tethered to reality. Our entire experience is this beautiful dance between what our brain expects and what the world delivers. Section 2. The Evidence Part 1. Optical Illusions. If this is true, if perception is a construction project happening in your head, then it shouldn't be perfect, and we have proof all around us that it's not. That's where optical illusions come in. They aren't just fun little brain teasers. They're windows into how this prediction machine works. You've probably seen the famous checker shadow illusion. It's a checkerboard with a cylinder casting a shadow over it. There are two squares, A and B. Square A is out in the open, and square B is in the shadow. Easy, right? To your brain, it is absolutely, undeniably obvious that A is a dark square and B is a light square. But that's a complete fabrication. If you were to actually measure the pixels, the light coming off of both squares is exactly the same shade of gray. So why do we see them so differently? Because your brain isn't just measuring light. It's using its experience. It has learned over a lifetime that shadows make things look darker. So when it sees square B in a shadow, it predicts that the square must be a lighter color being darkened by the shadow. It corrects for the shadow and generates the experience of a light square. It changes your perception to fit its guess about reality, not the raw data hitting your retina. This isn't a glitch. It's your predictive brain working perfectly, making a smart bet based on incomplete information. Section 3. The Evidence Part 2. Hallucinating yourself. Okay, so our brains can be tricked by visual illusions. But this theory goes so much deeper. It's not just our perception of the world that's a controlled hallucination, but our perception of ourselves too. The feeling that you live inside a body, that your arms and legs belong to you, that's not a given. That's another one of the brain's best guesses. The most mind-bending example of this is the rubber hand illusion. It's a simple but profound experiment. You sit at a table and hide one of your hands behind a screen. A fake rubber hand is placed on the table where your real one would be. Then, someone starts stroking both your hidden real hand and the visible rubber hand with paintbrushes in perfect sync. For the first minute or so, it just feels a little weird. But then, something amazing happens. Your brain is getting two sets of data: the feeling of being stroked on your hidden hand, and the sight of the rubber hand being stroked in the exact same way, at the exact same time. Your brain scrambles to find the best explanation for this bizarre correlation, and the conclusion it lands on is wild. That rubber hand must be my hand. People report feeling the brush strokes coming from the fake hand. They start to feel like they own it. The illusion is so powerful that if the experimenter suddenly smashes the rubber hand with a hammer, the person will gasp and pull back as if their own hand were in danger. This reveals something incredible. Your sense of self, the basic feeling of what is and isn't you, is also a perception. It's a best guess, actively generated by the brain. Your experience of having a body is just as much a controlled hallucination as the color of the sky. Section 4. The Implications. Different brains, different realities. So, if all of our perceptions are built from the inside out, it leads to a truly profound idea. None of us are experiencing the exact same reality. Because your brain's predictive model is built from your unique life, your memories, your culture, and your biology, your hallucination of the world will be slightly different from mine. Most of the time, the differences are small enough that we can agree on the basics. We call that consensus reality. But sometimes, the differences become glaringly obvious. Remember the dress? That viral photo from 2015 that tore the internet apart? Half the world saw it as blue and black. The other half saw it as white and gold. There was no single right answer. The photo itself was ambiguous, especially the lighting. So people's brains made different assumptions about whether the dress was in shadow or bright light. And based on that initial guess, their brains literally generated a different experience of color. It was a stunning, global reminder that our individual realities can be fundamentally different. The world doesn't just hand us its colors, our brains create them. And how we create them depends on the unique prediction machine in each of our skulls. This idea can foster a kind of empathy. When you disagree with someone, it might not just be a difference of opinion. You might, quite literally, be experiencing two different worlds. This framework also helps us understand mental health. Conditions like schizophrenia, for instance, can be seen as the control part of the controlled hallucination breaking down. The brain's top-down predictions become too powerful and aren't being corrected by sensory data from the world. It's not a broken brain, but a brain doing its best to make sense of things with an imbalanced predictive system. This whole idea of predictive processing is completely changing how we understand ourselves. It connects perception, emotion, and even our sense of self into one unified theory. But it's also a really personal idea. I want to know how it lands with you. When you look around now, does the world feel any different? Drop your thoughts in the comments. And if you're into exploring the nature of reality like this, make sure to subscribe and hit the bell, because we are just getting started. Conclusion. The thought that we hallucinate our reality can be a bit jarring. It seems to pull the rug out from under everything we know. But it doesn't mean nothing is real, or that we're living in some kind of matrix. The world out there is very real. It's the source of the signals that keep our perceptions anchored. But our experience of that world is not a direct copy. Our consciousness is less about being a perfect computer and more about being a living organism trying to survive. Our perceptions aren't designed to show us objective truth. They're designed to be useful. We don't see the world as it is. We see it in a way that helps us stay alive. We are all the artists of our own reality, a masterpiece painted by the brain. So the next time you look at a sunset, just remember, you're not just seeing it, you're creating it.